Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about software-defined radio. So let's dive right into it. Now first, what is this idea of software-defined radio? One thing you have to understand that we use radio in everything. Even though most people when they hear about radio, they think about this old AM or FM radio. But reality is everything we do right now still uses radio, and tools that we used to make for these sort of things, basically air receiver for ham radio or aircraft radio or walkie-talkies, these are all radio tools. That is absolutely true. However, they were very tailor-made. Basically they were designed to let's say if radio spectrum is this big, it was designed to work inside a very narrow spectrum. Now because we started to use multiple bands for multiple things, for example, even in your own household you will find Wi-Fi has like two spectrum, 2.5 gigahertz and 5 gigahertz, and mobile phone has even higher gigahertz than that in some cases, specifically with 5G. So you get the point. Like we are utilizing radio still, but we are utilizing much larger spectrum. It's like for FM, listen to this spectrum. For air traffic control, listen to the spectrum that is just side to it. For long range communication, go to below that. So you get the point. Like we are utilizing a whole band nowadays. So we need something that gives us the flexibility equivalent of a software, where basically somehow figure out a way to feed the basically radio data to computer, and computer sorts all this out. It's like, dude, this is the spectrum, this is the frequency, this is what we have to do in order to listen to it. And this also allows advanced things like digital radios also, because again that inherently requires digital description. So that's the idea with this. Like we are utilizing radio more and more. So what if we have tool that has flexibility of software? Here goes software defined radio. Now bands are the primary aspect of it. That's the primary reason these sort of things exist. So, and the fact that we almost everything uses bands. One of these bands, basically we have aircraft, satellite, mobile phone, FM, everything else also uses these systems. There are different naming convention, and this is where radio becomes very frustrating to deal with. Basically if you're talking about military speak, most of the military speak would be like in A band. Why? Because A band extends up to almost 500 megahertz. Anything basically any radio that is working below that, military will call it, they are utilizing A band radio. And if they are like spying on some other satellites and those sort of systems, satellite is using something, let's say 1 gigahertz, they will say we are spying on C band. Now this convention is generally not used for common public speak, so don't focus on that, but we do utilize in International Electrical Council sort of stuff. So they have naming convention that is half naming convention and half fancy hoo-ha. So we have high frequency, makes sense, similar to basically radio communication. We have very high frequency, makes sense. Ultra high frequency, now this is where it gets complicated. Ultra high frequency ends very shortly. Basically it ends at almost 1 gigahertz. The moment you go higher than that, you go into later category. You have L band, you have S band, you have C band, you have X band, you have K under band, K band, K above band, and then you have V band, W band, and MM, millimeter waves band, which was supposed to be used for 5G, but everybody realized that 5G is a good joke because the range transmission is so low that they are like, let's just rebrand 4G into 5G. So that's why like every 5G phone is like elevated 5G, where it has the range of 4G. I'm like, no, it's just 4G. So that's the whole point. And one core aspect that you have to understand is that lower frequency, lower the range. Basically the frequency, the lower you go, the further you can go, and I'm talking about the same amount of power. And apparently there is like an extremely low frequency radio that is used to communicate with submarine. Yes, like again the bandwidth is very little, like even sending Morse code is very difficult, but you can communicate to a submarine. Let that sink in. Like you can communicate through water body. Water is like really bad, opaque for almost all radio stuff, and yet you can communicate through it if you are utilizing that is signal that is looks almost DC. So that's what we are talking about here. You have multiple bands, and in radio world we have naming convention that is a bit more similar. You have very low frequency, you have low frequency, medium frequency, high frequency. This is what we start to utilize. This is like common things. Then you have VHF, fancy way of showing in a Star Trek movie. They started to show VHF was used. Then there we have something even more extreme, ultra high frequency, and then they ran out of cool names, so they have super high frequency. It's like ultra is before super. It's like who named this? Then we have extremely high frequency, and then we have terahertz frequency. So you get this point. Like these things are idiotically complicated, and when you go into ham radio world, they have another naming convention where they are like, this is 6-meter band, this is 3-meter band, this is 2-meter band. I'm like, why? Like at this point in time, if you ever confused, just utilize one simple thing. call out the actual symbol. Like just for example, I liked one FM station that is 104 megahertz. Just say that. At that point in time, it does not matter which band you are utilizing. Anybody hearing is like 104.1 megahertz, they will directly tune into the right band, right stuff, whatever. It's like this naming conventions are really, really bad. And it's like 6 meters, 7 meters, just call out the frequency, just call out the goddamn frequency. So these are the bands. And if you want to understand where the basically radio starts and microwave starts, microwave is generally classified as anything above 300 megahertz and anything below 300 gigahertz. So this is what we are talking about. Now, antennas, this is the first thing that your radio waves is going to interact with, and it is a completely independent field of study. Basically, there are engineers whose sole job is just to make goddamn antennas. And this 5G technology, apparently there are horror stories like how difficult it was to make 5G antennas. And if you want to know the difficulty of making antennas, remember this: iPhone 4, the engineer did not did the proper testing, and consequence of that, if you hold the phone right, it will drop all the signals simply because your hand was in the wrong place. Wrong place as in like the phone was designed inappropriately and not tested. And that's why, because it was Apple, so they're like, you are holding it wrong. So but you get the point. Like, antenna design is a completely independent field. And if you're old enough, you know mobile used to have actual antennas, then they had small snubby antennas, and now they don't have antennas, and that took insane amount of engineering. If you actually go down and try to study like what goes into that, it almost sounds like voodoo magic. So it's a completely different field of study, but that does not mean you can't do this. This is like a overview. You have to have PhD. Those are generally reserved for very high frequency and very high efficiency antenna. But if you are doing basic stuff, it can be done homemade. Specifically for lower frequency, you can easily do it at home, and this will be the main limitation of your performance, because it's almost like how a camera works. Basically, you can have the most amazing camera, like most amazing sensor, 60 megapixel, amazing stacked sensor, what hoo la 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 and jinga la la, but if you have a crappy lens, you're gonna get poop out of it. That's it. Same happens here. If you have a good radio receiver, basically good SDR, let's say like Air Spy Discovery, a good SDR, but the signal coming into it is garbage, this is gonna spit out garbage. It's like how computers are, like garbage in, garbage out. So you have to understand this is the main limiting factor of your system. And there are many designs, many spectrum, many fine tunings that are done. Like for this band, make this antenna; for that band, make this antenna; for receiving from satellite, make this antenna. You get the point. So you have like very simple systems like dipoles, monopoles. All things are DIY. You can do that yourself, but be mindful. It will take time. You will not just start like, oh, I'm going to make one and everything's going to work fine. No, even though people who have successfully get it to one, they will like do there about packet loss and all that jazz. There is a reason why proper antenna costs such a large amount of money. But antenna is your first starting point. If you don't have a good antenna, do not blame the SDR. Now, what are the tools you need to actually utilize this? First, antenna is the first starting point. Good antenna is a must. And for Indian viewers, I would urge one thing is basically most SDRs that you will buy generally will have SMA connector. These are like generally gold yellow ones, and these are very difficult to find in India unless you live in a big city. But because India has such a large proliferation of dish TV, we can easily find F-jack connector. So just buy one converter. Both are designed for coaxial systems. Just buy F connector and you will be done. Like, and I will provide the Amazon links down below. So once you have this connector, everything is golden. At that point in time, you can utilize easily available parts, and then you can have like, you know, proper wiring, proper lightning connection, lightning arrestor, all those things. You can easily do that. So for those reason, I would urge you to buy the connector. That's the first thing you should buy. And if you are not comfortable buying those sort of things, you can buy antennas that come with SMA jacks directly, but be mindful, these are generally very expensive and very small. Like this is costed me around 500 rupees. That's a lot, although cable is long, and these are generally car antennas. You can even buy them in car shops, so do check there. You will find it cheaper there rather than buying on Amazon. And they're good, they do work, but they need a ground plane. Be mindful, that's why this magnet is there. They need a ground plane. And I will provide a link of this one and a taller one that is like 12 inches. This is 8 inches. So better the antenna, better the resolution. That's the first step. So you can do start with that, or you can even utilize something like this. If FM is your primary focus, you can utilize this sort of antenna also, called loop antenna. I'm pretty sure if you have a deck that may come with this antenna in the box. So that's the first step. Then you have to have the radio itself. Radio does not mean like only AirSpy. This one is the option. You can utilize some AirSpy quote unquote brick one. I have not taken it out of the box yet. And then you have very small ones which are like almost that is basically designed with, you have a small antenna, you plug this in utilizing OTG cable. You can plug this puppy into a mobile phone and Android specifically, and listen to air traffic control. So if you are in an airport and you're bored, you can use this puppy to listen to air traffic control. Listen, do not transmit. And not to mention, I don't even think any small ones are capable of transmitting. So these are the two first things. You have to have antenna in terms of hardware. You have to have connector if you want to, like, you know, wire the whole system. Permanent installation does require those sort of thing. And after that, you have to have software. Now be mindful, these softwares are complicated. These softwares are not designed for common person to use. It's like almost like Photoshop or video editor. It's like if common person looks at it, it's like, what the hell is this? But that happens because inherently this is a complicated system. Inherently this system is wideband. It's like I can listen from like almost DC level signal to almost AC level basically very high frequency signals. So it has like a sort of, you have to learn how to use this. Do not blame this software. These softwares are complicated, and I would urge you to have patience with them. So one software you will hear a lot to be used, made by the same people who make this equipment, AirSpy basically, and it's very popular. And there are many add-ons, plugins which you can add to improve the functionality. And there is also GNU radio, and there are many more. But be very mindful, if you are buying a radio and it does not have like a software associated with it, try to stay away from them, because if the software part is not working properly, you may get stuck. You may be like, hey, I have the best antenna. Heck, even the hardware itself may be the mind-bogglingly awesome, but if the hardware and software are not talking together, the end. So be very mindful. And this is the primary reason many times people are just like, dude, I'm gonna buy this company's hardware with this company's software because I do not want to deal with incompatibility or extra hoo-ha. So be mindful of those things. Then we come to the hacking part of it, because this SDR is generally associated with, like, evil things and hacking things, and because of the movies and TV shows, people think this is hacking. And not to mention, there is a freaking hardware that is actually sold as Hack RF1. Every Tom, Dick and Harry thinks this is about hacking. Now be mindful, there are certain bands, even though they are unencrypted, you should not listen to. Now if you are a criminal, it does not matter. That's how like police radios were like tapped into for very long. That's what you see in the TV shows. It's like, hey, police is coming, police is coming, police is dispatched. How the heck they are listening to that? Because it was using unencrypted system. Now after those sort of thing became very popular and every police officer was dealing with that, I said, dude, why the heck they are running the moment I'm leaving the office? It's like, yeah, they heard that you are coming. So police has wisened up. Now they are using encrypted system, and flat out there are laws that you should not listen to that. So if you have a recording from that, try to delete it as quickly as possible. And please check your local regulation. Do not check, oh, what is the law in USA. Check what is law in India. Check what is law in Pakistan, what is law in Nepal. Be very cautious. Other than that, most of the time listening is okay, you do not have to think about it. However, radio transmission has strict laws, even in amateur band. Even when you see the amateur radio and you think it's amateur, it's not commercial, that's absolutely true. But there is a law, regulation, which bands you can use, which what amount of power you can utilize, everything. There is some serious regulation in this puppy. So be very mindful. And India, you have to get a exam, and you have to clear that exam. And if you clear the exam in 1 hour, you get basically general license. If you take 2 hours, you will take around limited license. So be very mindful about that. And if you try to basically hack any digital signal which is encrypted, you still have to decrypt it. This puppy will only spit out the actual data. You still have to decrypt it. Be very mindful. That's why the hacking part you still have to. This is just a radio, and the hacking that people show utilizing these things, they are generally very old system where they are utilizing an old radio code which nobody could easily copy. But nowadays, because we have such an advanced technology, it's like copy, paste, done, go home. So be very mindful. This is not a hacking tool. You can utilize it as such, but it's not a hacking tool. It will not do hacking for you. So this was my presentation on SDR, and I still have a lot to learn, and now I have tools and I will do much more experimenting with it. So I hope you like this, learn from it. In that case, please click the like button, share it amongst your friend. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.